Can everyone hear me? Folks in the back? Thumbs up. All right, the mic is working. So like Juan said, I'm Matt, and I'm here to talk about TypeScript. So this is a Java developer group. So I'm not normally a Java programmer. I've been doing front end and JavaScript for the last several years. So I'm a little out of place. So I solicited on Twitter, like, what should I do to bridge that gap? And I said, give me an auto-boxing joke that I can hit the Java folks with. So Juan, responded and said, let's just call this putting the Java back in JavaScript. So the theme of today is, how your boss, from several years ago always kept confusing Java and JavaScript? Well, the good news is that this is finally a reality, and its name is TypeScript. So like I said, I started off, when I came out of college, I was a Java programmer. I worked on big backend systems, did a whole lot of XML over SOAP, JMS messaging. I built a whole lot of applications that ran on BEA WebLogic before Oracle bought them. So I'm at least, I'm somewhat familiar with the way that Java works. But I moved over to the front end, and back in the days of jQuery, and did a whole bunch of UI development there, and it felt liberating. Oh man, the fact that I didn't have to run a compiler, it felt like all the shackles had been released from me. But there's still some things that I don't like about working in the front end that I miss from my days as working with Java-C. This is like in the Java 1.6 days, and in the JavaScript, let's just cross our fingers and hope that it works on IE6 era. So there's a couple, but if you talk to people on the front end, they'll tell you, there's a beautiful language in JavaScript. You just have to know which sections of the language to familiarize yourself with and which parts to avoid. There's an entire book about this called JavaScript, The Good Parts. The problem is that if you compare the good parts of JavaScript to the rest of it, there's a lot of really rough edges that you have to be aware of, and unless you have a very intimate familiarity with some of those rough edges, they can come back to bite you in really unexpected ways. So there's a great website called WTF.js that catalogs some of these. So let's say that you have two lists that contain 1, 2, and 3, and then you try to add that to 4, 5, and 6. What do you think the result of this expression is on a standard JavaScript engine that's following all the specs? 579? Okay, not bad. You're wrong, but
not a number.
Not a number? So the answer, it is technically not a number, but the answer is that you get a string back. This is according to the JavaScript specification. Let's say that you had a function called person. You can new this up. So in JavaScript, functions are objects. So you can pass data, you can set values on this, and you can return values. So what do you think that the result of Alice is in this case? We're newing up a person, passing in the string of Alice, but we're returning a different name of Bob. So yep, so it makes sense, right? It's Bob. So let's ask, well, is Alice an instance of a person? This is the type of check. Not even close. So the answer is false. So let's try this again. Maybe we can return an array with 1, 2, and 3. So what do you think that Alice is in this case? So it's 1, 2, 3, right? So let's try and return something different. So let's say we return 3 from this case. What do you think the value of Alice is? 3. You get Alice back.
What?
So exactly, WTF.js. And the answer, if you look into the specification, is that if you try and call a function as a constructor object, or if you new it up, then you can return a different value. But if that value is a primitive, then JavaScript ignores the thing that you returned and returns back the original object. So it's like you didn't return anything in the first case. There's no legitimate reason for this, other than the fact that this was developed in Brendan Eich's insane addled mind on day 11 of his 12-day JavaScript coding binge, right? But we have to live with this for the rest of time as a result, right? And in this case, Alice is a person, right? All the other instances it was false. In this case, it's true. This just makes you want to pull your hair out in some cases. One of the other problems that I run into a lot is just that we are spoiled in the Java world with all the amazing tooling that is available. right? As much as you like to joke about having to download the like 400 megabyte IntelliJ or Eclipse binaries, like there's a lot of just amazing engineering that folks have put, like whether it's JetBrains or IBM, like developers, like they've put years of person hours or person years into building out these amazing tools. Right? If you just look at the refactor list from IntelliJ, like there's so many safe things that you can do to an entire code base that allow you to upkeep and maintain it. On the JavaScript side, we have been lucky if we can rename a variable in the context of a single file without it breaking something else. And that's just because that our tooling has been kind of garbage for the last like 10 years. You know, even the state-of-the-art stuff that IntelliJ would put out with WebStorm still is just trying to guess in a lot of cases. And some of this comes from the fact that it's just a naturally flexible, dynamic language, but there's a cost that happens every single day as a result of it. Like we as developers are bearing that brunt. You know, because that it's a dynamic language, the only way that you can check in JavaScript whether or not you have a problem is to load it up on a server and get errors at, you know, check to see whether or not your errors are occurring at runtime. So this hurts your feedback cycle, right? Because now, as I'm typing, I can't see if I'm typoing a problem or if I messed up one of my functions, if that no longer exists. I have to go to a browser, hit refresh, and hope that it actually runs. You know, it's weird that a dynamic language has a slower feedback cycle than waiting for compile time errors in the Java world. But that's the crazy world that we're in, and so that's a problem. And one of the problems that's recently come up is just the fact that JavaScript as a language is changing like crazy at the moment. You know, so if you've developed at all and you've heard of ES6 or ES 2017 or ES 3030, I think ES 2048 is a new movie that's coming out pretty soon. But there are all these new specifications in the language that are adding really important primitives that you just might not be aware of. So the JavaScript that you wrote 4 years ago might look completely different from the JavaScript that you're writing today. And that's just on the standard side. If you're looking at the module formats, so JavaScript just got the structure for modules to be able to import and export files, but only some browsers have it and Node.js doesn't have it. So there are these competing module formats that you also have to deal with. And there's just a ton of churn around that. So maybe you want to try to solve these with tools. And so there's a bunch of tooling that's all kind of non-standard that's trying to bundle these all in together. So if you've ever had, like, you know, hell is another person's Webpack configuration. If you've ever had to work on the front end and try and understand the house of cards that you know, some of these bundlers are trying to do to wrangle all of the complexity that modern JavaScript has, like you're just going to pull your hair out. It's terrible. So, you know, you might say, well, I'm just going to abandon JavaScript. There's too many problems. It's, you know, it's too much of a churn for me to deal with. I'm just going to write my code in Java and use GWT or Wicket to compile it down to JavaScript, and I'm going to be done with it. I wipe my hands of this whole affair. But I mean, I still like JavaScript as a language, and there's still practical reasons for why you would want to work with the language. Like NPM as a third-party module is the single biggest repository of third-party code on the planet. You know, there's hundreds of thousands of packages that can solve most of your problems for you automatically. And you know, JavaScript has the biggest runtime environment. It runs basically everywhere. You know, so there's still stuff that you want to have, but how do you square that circle? I think the answer is not to just abandon JavaScript, but instead to use TypeScript. So TypeScript is just a superset on top of the JavaScript language that adds types, along with a couple of other things. But what I want to talk about today are the typing aspects of it, and why I think that it solves a lot of the problems that I've been experiencing building stuff in JavaScript. You know, I'm really excited about it as a language. I think that there's a lot of cool stuff, and you know, I'm pretty much going full in, and I think that it fits really well with Java developers. So so my goal today is to get you to go back to your desk tomorrow and try and build something in TypeScript. So does anyone know Anders, or how to pronounce his last name by chance?
Heilsberg.
Heilsberg, thank you. So Anders Heilsberg, if anything, he should be like your enemy as a Java developer. So he was one of the original language architects at Borland. He made Turbo Pascal and Delphi, and then Microsoft hijacked him, stole him to work on the language specification for C#. And the hit for C# is that Anders looked at Java and was like, oh, that's a cool language. I can make it better. So he just took Java, added some additional features that Java didn't have, like it didn't have closures until just recently. C# has had it for years now. Dynamic like type inference. There's a whole bunch of stuff that Anders added in and made a pretty solid language out of it. So then Microsoft said, okay, you solved the stuff on the back end. Can you also fix this on the front end? And so Anders was like, yeah, I can do that, but JavaScript is kind of garbage. Can I add some types on top of it? And so Microsoft used it internally for several years before they open sourced it back in 2011. So this is around the same time as like Java 7 or 2012. So TypeScript is about 5 years old now, which if you think about it is around the same time that Java 7 came out. So so it's not particularly, it's not a spring chicken, and it's been used in multiple extremely large projects, both internal to Microsoft and external in the open source world. So there's a couple of things that I really like about TypeScript. One is that it works very well. Like one of the core tenets of TypeScript is that they want it to play well with the existing JavaScript ecosystem. So they're not making major structural changes to the language. They're building it as a superset. So it kind of works, so it works very pragmatically. So all of your JavaScript code is valid TypeScript code. You just have to change the file extension. It kind of reminds me of Groovy in that way. But then you can add in additional types and features to your JavaScript code to give it additional superpowers. The other cool thing is that as JavaScript the language has been changing, then TypeScript has been very pragmatic about incorporating those features into the language. But they do it with a particular stop gate. So you don't have to worry about, well, I'm using this weird language offshoot that was popular back in 2017. Like, no, it's keeping up with the times as well. So it gives you the best of all worlds. Stack Overflow did a developer survey earlier this year, and the thing that I like to see is that TypeScript came in very popular for the developers that are using it. Right? So TypeScript is number 3 on all of the most loved languages that people are working on. You have to scroll down a fair amount until you see JavaScript, and then if you keep scrolling down a little more, oh, what's that down there?
Oh, Clojure's above JavaScript.
Oh yeah, the Clojure developers love working in Clojure, but the TypeScript developers love it even more. So I don't know. I find that it's just a joy to work with. I have the ability to add in the things that I missed about working in the Java world, but I can do it in the front end and still work on websites. So a brief overview of how types in TypeScript work. So this is valid JavaScript. You have a function add, takes 2 parameters a and b, and it returns the sum of them. This is the same function in TypeScript. So it looks more like the types are on the right-hand side of the thing that they are declaring. Looks kind of the way that Golang does. But you just put a colon and then the type that you have. So A is a number, B is a number, sum is a number. They're all numbers. And TypeScript will enforce this. If you try and pass in a string, you'll get an error. It knows that total is a number, so all of the pieces just kind of work the way that you would expect them to. So this should look pretty familiar to you. One of the cool things about TypeScript is that it does what's called type inference. So you don't have to declare your types. TypeScript, the compiler, can read the shape of your code and the way that it executes and determine with pretty impressive functionality like what all the types are, so you never have to write any of your code, but you still get type safety out of it. So TypeScript Playground is a pretty cool website. So the TypeScript compiler is also written in TypeScript, which means that it can run basically anywhere, including inside of a browser. So this is that same code. If I hover over it, then I can see that total is a number. If I try to change this to a string, then it'll fail and it says that 2 isn't a number, right? And so that kind of makes sense. You can just hover over things and you can see that sum is a number, but I didn't declare that sum was a number. It knew that it was a number because that I'm taking A and B and adding them together. And then this is the JavaScript that gets compiled, right? In this case, there's not a whole lot extra that TypeScript is adding in. In fact, it looks very much like the JavaScript that a human being would write, and that's one of the other design goals, is that it doesn't want to produce, this weird, crazy, there's no bytecode that's coming out on the back end. It looks very much like source code. Yes?
With type inference, how do you know how much you have to type?
So with type inference, you don't have to type anything. But if you want type safety, then there are different levels of compiler strictness that you can add in. And if TypeScript can't infer the type that it has, then out of the box, it gives what's called an implicit any. And I'll talk about that a little more in a bit.
So I'm assuming there's a way to turn that off.
Yes.
So, you can say, I don't want to.
Yes, there's a number of.
Implicit any or whatever.
Yep. So there's just different compiler options, and you can gradually increase the ratchet up the strictness until you have full type safety across your entire application. But you don't have to start there. So TypeScript works also very, very well with objects. So in this case, I have a get math functions where I just take a base, and that is a number. And it returns an object, and that object has different methods on it. So you have square, which it takes the base times base, stringed, which just takes the base and adds it to string, right? And if you look at the compiled options, you can see that functions is of this type. And so I can say functions dot, and it knows that square and stringed are functions on it. And if I call square, it knows that there are no parameters on it. And then I can hit dot, and it knows that the result of square is a number. So it knows that if I call .toString, so this is a string, which means that now I can call string functions on it, right? It is chained and has given all this in a type-safe way. It's not trying to guess what these values are, but TypeScript knows based on the shape of the object. And if it doesn't know, then it'll give you that implicit any. So this feels more powerful both in Java and as well as any duck type languages where it's based on the shape, but it still allows it to go through at runtime. Again, you kind of get the best of all possible worlds. I don't know. Anders is a genius at this stuff. It just blows my mind how often this stuff works. TypeScript also has interfaces, so you don't have to declare the types that are being returned if you have complex objects, but you might want to give it a name. And so an interface in this case, looks pretty similar to a Java interface. So this map functions is just an object that has a couple of methods on it. So square is a function that takes no parameters and returns a number. Stringed works the same way. And then you can say that this get math functions returns an object of type math functions. And again, this, just kind of works the way that you would expect it to. So now if I hover over functions, it knows that this is a math functions object. But this also means that because this function is returning an object of this type, that if I change the contract somehow, then I'll get a compiler error. So if I say, value is another number, oh no, I got to do it the other way because you can pass in options. So if I say that square in this case, now it's giving me a compiler error saying that this doesn't match the contract of the interface that I've defined. TypeScript will still emit it, but you can get compiler errors and you can break your build or do other, make sure that you're not pushing out code that breaks the contracts that you've defined. So if you want to name your interfaces, you can, but that was one of the kind of liberating things about TypeScript compared to in Java, where I felt like there was just a ton of times where I would have to declare interfaces just so that I could get a type where I wanted to have some level of indirection between the interface and the base implementation. You don't have to do any of that stuff, but TypeScript still allows you to build those as well. You can return complex object just as data. So in this case, and those can be recursive definitions. So I have this sum up function that takes a parameter of data, which is a complex object. And that complex object has different numbers on it, and then there's an optional property on that object that is another complex object. And then there's just some functions that say, like, if this, if there is a sub on it, then call it. Otherwise, it can return it recursively. So in this case, why is this? Because it does not. Oh, right. So in this case, TypeScript couldn't infer the type that was being returned. So I have to actually tell it that it's a number. And then I can call, sum up, and I can pass in my different values. So, first, 42, second, 43. And then it knows that the only property that I haven't specified on here yet is sub. So I can put a sub on here, put my own first, second. And so now, again, it's define the stuff on the Java side, and if I run it, I actually should probably call this. So now, if I do a console.log result, oh no, I hit Apple R instead of Control R. That's all right. TypeScript is pretty fast with its compiler. So, and then this is all just running on my browser. Hey, 170. So, but again, the thing that I missed in the JavaScript world was just being able to control period or control space my way through a big, long set of APIs that I wasn't familiar with. And I have this back again. It auto-completed most of my code for me. This was, just my mind was exploding every time that I got to play with it. So,
I'm sorry, could you explain what I must have missed what?
Yes, so this is the TypeScript code on the left side.
Okay.
On the right side is the JavaScript code that gets compiled down.
Oh, that's what he meant.
Yes.
Okay,
yep.
Thank you.
So, and the way that I have this set up, so you can tell it to compile to different JavaScript targets. So in this case, it's running on ES5, which basically means that it runs on IE9 and above. You can have it target ES 2015, in which case it changes the vars to consts. So they work in additional browsers, or you can bring it all the way down. So this one doesn't show it. You can bring it all the way down to ES3, so that your TypeScript code could run on a shoe.
So IE3.
So IE3, yeah, exactly. So you have tons of different options here. So if you want to specify arrays, you can do that pretty easily. I find that the syntax is cleaner than Java's arrays or generics. But in this case, if you have a set of Fibonacci numbers, right, this is just a number with braces, and that just means that this is an array that contains nothing but numbers. If you try and put something different in there, it'll fail. TypeScript also has the concept of tuples, which is just a set of multiple values inside of an array. So in this case, I have some mixed data, which contains 6 values that alternate between numbers and strings. So, and if I run this, don't need those, right? So this should compile down and just give you your mixed data. But if I mess this up in any way, so if I remove one, then I get a compiler error, and it says, hey, you forgot to add a value here. Or if I put a string in, then it'll also give me a compiler error there. So tuples are just built in directly.
Is that immutable? Immutable within your TypeScript there?
No, so TypeScript isn't adding any immutability. It's not really modifying your JavaScript code. It's just a declaration of the type of object. It's just saying what shape it has. It's not trying to add in additional functionality. In fact, TypeScript doesn't, so one of the things that, the end result of that is that because it's not adding any opinions on top, the compiled TypeScript code is usually about the same size as your original JavaScript. So there's, it's not doing any additional work there. So you can also do what are called union types. So I think Scala might have this. I forget what other languages, but you can specify that in this case you have an array that contains either numbers or strings, and it doesn't matter what order they are, but as long as so it creates a new type based on those 2 original types. They don't have to be primitives. You can pass in whatever 2 values, and it's just going to automatically create a new type that says as long as it satisfies one of these 2 conditions, then that's allowed. So again, I found this to be really powerful, especially when you have a function that can take either one value or a list of values. It's very easy to set that up so that you just pipe it and either say that it's an object or it's an array of objects.
Quick question.
Yes.
I've noticed quite a bit of declarations in the material in Angular and Angular material are having the type declaration of the output of the function, either some sort of type and then null. It's separate. Why are they doing that?
So help me understand. So in Angular code,
like validate function, they have a declaration of valid function or null.
So one of the things that TypeScript can provide is it wants to ensure type safety. So let's say that you are doing a document.query selector. The result of that can either be an HTML element or it can be null. Like it's perfectly valid, it's within the DOM's spec to return null back. So TypeScript can warn you about that. So if you get a value back and that value is nullable, then you have to check for that. Otherwise, you don't have type safety, right? You get a null pointer exception, or the undefined is not a function type of error. So I'm guessing that's probably why you're seeing that. But we'd have to look at some more specifics. There are ways to change the TypeScript compiler to have less strict null checks, but usually it's fairly, it gives you another piece of rigor to validate that the thing that you're working with is actually defined and isn't a null value.
This is the thing I for a couple of years I was in touch in the back end, and right now I'm back to the to the front end. And now I'm back to the front end, and the project that I started, it's the first time using TypeScript and all that. So there was a learning curve, and I was like, are they actually enforcing a type safety like that, or it's just ID flavor?
Right. So it's a little bit of both. So it doesn't do any enforcement at runtime, but it does give you strong type safety during your check. So in this case, if you do a document.query selector, so if I just want to find the HTML value, then val, strict null checks. Let me turn this on. Yes. So because that document.query selector can return null, it will tell you about that. And then if I try to do something with this, val dot inner, this is going to fail because that this value is possibly null. But one of the cool things about TypeScript is that you can perform a check, and inside of that, so if I say if val dot, yeah, exactly. So now it knows that so because that I've done an if check, it knows that it can't possibly be null inside of this if statement, and so val is now just an HTML element. So again, you get type safety at compile time to verify that your code is doing the things that you want, which is pretty slick to me.
You can also at the end of line 4 put an exclamation point, and that tells it that it's explicitly never going to be null.
Oh man, right here? Yep. What? You're blowing my mind.
So it will.
So now it's
enforce that as never null.
Yeah. Thank you, Nick.
That's why it's called YOLO.
Right. This is the bang important of TypeScript. So there is a way to kind of opt out of type checking, and that's by using the any type. So if for whatever reason the data is dynamic, or you just don't want to have to deal with typing for whatever reason, you can say that something is of type any, and TypeScript will allow that and just won't perform any type checking on that object. So in this case, if I have a third-party API call, I can just say that it's of type any, and then I can say something .return data, and that will TypeScript won't complain at you if it doesn't know about the shape of that object. So it's a fairly pragmatic way to continue to perform work on a part of your code base, even if you don't want to explicitly add types for everything. Again, use it cautiously, right? You're losing type safety as a result of this, but there's times when you just want to get work done. So I don't think that we're all Java folks here, so I think that I have a general, you're sold on the reason of using types. Juan is shaking his head. But the way that I like to think about it is that I tend to make the argument that you should test until your fear of the code that you're writing turns to boredom. And there's an entire category of unit tests that you just don't have to write if you have strong types, because the compiler is verifying that just the data that you are passing from one section of your code to another all has the same shape. So there's just an entire category of unit tests that I feel like I don't have to write, and I am still guaranteed some level of correctness about my code base. So I really like that as a feature. And there's some data that backs this up. So there was a study done at the University College in London where they took a number of public bugs that were captured in JavaScript projects, and they took those changes and said, well, if these projects had types in them, would those bugs have been committed to the code base in the first case, or in the first place? And what they found was that for a statistically significant size of real-world JavaScript projects that had the developers use types, that they could have captured 15% of the public bug reports before they were ever pushed up to production, right? If you could say that changing one part of your methodology would remove 15% of your bugs, I would sign up for that in a heartbeat, especially if it also helps you with your standard day-to-day work. And that's the proposition that TypeScript can give you. Sweet, man. So there's a couple of things that are similar to Java. So types are erased at runtime. It's kind of the way that generics work. So that has good and downsides, right? The good side is that there's no runtime, quote unquote, that gets passed along with TypeScript, which means that it performs very well and it looks very much like code that you would be writing. The downside is that if you want to check the type at runtime, right, you just can't do that. So you have to live with it. But I think that the TypeScript's type system is better than Java in a couple of ways, right? So we've already seen the way that you can infer types. So you don't have to declare types on every single one of your values. It just kind of works. Oh no, that broke. So you also have incremental typing, which means that if you add types to one section of your code base, that as far as the TypeScript compiler can infer those types, it will just continue to expand out in your code base. And it feels like the TypeScript compiler gets better with that with every release. That if you were to go back, that you would have to add in fewer tokens as time goes on, and you still have a very impressive amount of type safety inside of a code base. The fact that you have union type string literals, I'm still waiting for the day where I can just say this is a string of yes or no. Like in Java, you have to write an enum to do that, unless something has changed recently. But the fact that you can just say this is a string, and if I put the wrong value in my string, then I get a type error. That's amazing. I love that stuff. And there's no autoboxing, so I like that. There are a couple of other differences from the way the TypeScript type system works. So in Java, you have what's called one class of typing, which is called nominative typing. So in this case, I have two classes. One is named, and one is person. They both have a method on them that is getName, and they return a string. But if I try to type it by saying named p equals new person, then that'll give me a type error, because that person and named are two discrete types in your type system, and never the twain shall meet. So if you wanted to fix this, then you would have to have named and person both implement the same interface or extend from a base class and use those, but you end up having to work around the system. This is in contrast to the way the TypeScript system works, which is known as structural typing. So in this case, you can have a class of named and person, and then you can declare a type as named and then give it a different object. But because they both have the same type, there's no compiler errors here. So structural typing looks at the shape of the objects that are being passed in. And as long as those shapes match, then you have type safety. If those shapes ever don't match, then you get a type error. But this, again, means that there's an entire category of code that I feel like I don't have to write. There's been plenty of instances in the Java world where I would get an object that came back from the database, and I just wanted to pass it along to the front end. And for whatever reason, like my JAX-B bindings didn't work the way that they should have, or but I ended up having to write these mapping codes between two objects that were exactly the same. And so I would just have to copy parameters from one to the other, where it's like, I just want to pass in the same object that I already have. Like, let me do that. And structural typing gives you that, while also still giving you type safety. Right? I think that's a big difference between this and like Python's duck typing, where you don't have to, like where it basically lets you pass in whatever the hell that you want, but it checks it at runtime. Like this is a compiler time check, so if named and person ever diverge in the way that they implement, then you'll get a type error at compile time. So again, like this is what feels to me like the best of both worlds.
Does it check both fields and the members?
Yes. So anything that's part of the public API of it. So in this case, well, let's run the code and see what happens. So if I have named and person, right, these two should compile without an issue. But if I say do stuff, oh right, I need to actually give it an object. So now I get a compiler error saying, person is not assignable to type name. If I were to add those pieces back in, then that would be fine. But that is a good question. I don't remember. So I think that it takes like the minimal size. So in this case, if I say person, I do a new named, yes, that is allowed, because that person is a subset of named. But if named return, an array of strings, now it fails because the two don't have that same shape anymore. Excellent question. So there are a couple of other features that TypeScript has. You can use decorators, which look very much and behave very much like annotations in JavaScript. Angular uses this a lot in their code base. It's just a good way of adding metadata to your code. You can also specify public or private fields. So JavaScript has classes now, but it doesn't have any encapsulation. So if you want to say that something is a private field, there's no way of doing that in current JavaScript. In TypeScript, you can specify this. Now this is only a compile time check, so at runtime you can still get access to animal.name. But if you run this through the TypeScript compiler, it will give you a type error saying that name is private and you shouldn't be grabbing onto the innards. So again, you get some better encapsulation here. I was going to write out all the different editors that TypeScript has integration with, but the answer is basically everything that you want to work with. And the reason that this works is that Microsoft has a TypeScript language service that any editor can plug itself into. So if you're used to using kind of a JavaScript-specific editor, like Visual Studio Code or Atom or Sublime Text, TypeScript has great integration there. But if you want to work in WebStorm, that also works. If you want to work in Eclipse, you can actually have amazing TypeScript language autocompletion using some of the extensions that are available. I know that Nick is a big fan of using TypeScript in Vim. There's also an Emacs plugin. And I looked, and there's actually somebody that was working on a Notepad++ editor integration. So like basically the world is your oyster. I happen to be doing most of my work in Visual Studio Code these days, but you're not limited by your choice of editor. TypeScript works basically everywhere. In terms of the build steps, so TypeScript is a compiler, which means that you have to take your .ts code and turn it into .js code before you can run it in a browser. So you have to integrate it into some sort of build system. But again, here, it works pretty much everywhere that you would expect it to. So there's a command line compiler that works, it's called TSC, works very much the way that JavaC works. But I tend not to use that directly. Instead, you can use a front-end specific build tooling system. So if you want to run this inside of a Gulp build, or if you want to run this inside of Webpack, all of those are options. But there's also a number of JavaScript-specific tools. So if you want to run your code through a Maven plugin, that's available. There's a Gradle plugin that also will compile your TypeScript code. So again, it's fairly easy to add this into an existing code base because most of those tools have already been developed for you to use. Along that side, you probably, if you're working in a big JavaScript project, you have third-party modules that may not have been written in TypeScript. So in this case, Lodash, it's a utility toolkit that gives you functions like flatmap in JavaScript. Isn't written in JavaScript, but if you want to get type safety in your code base, you can do that by using a repository called definitely typed. And this adds what are called typing declaration files for pretty much any popular third-party module that's available on NPM. And once you add in those typing files, then you can get type safety and your control spaces across your entire code base, including that third-party libraries. Some editors, like Visual Studio Code, will pull down these typing files for you automatically. So in many cases, you don't even have to think about it. So again, you're not limiting yourself by writing your code in TypeScript, which is pretty damn sweet. In terms of how you migrate your application to TypeScript, again, there's a couple of steps that you can work in incrementally. So the first step is just to add in a build step. So whether that's running the TypeScript code directly, using Maven or like IntelliJ can also, you can just say every time that I save my code, compile my TypeScript and put it in an output folder somewhere. So it works the same way that your .class files work in Java. So that's step one. That's usually pretty easy to do. The next thing that you want to do is just rename all of your .js files to .ts and add in a couple of configuration files. And again, because the TypeScript is just a superset of JavaScript, this will all still work. You won't have type safety, and you might get some red squigglies everywhere, but you now have a valid TypeScript project that will compile down to JavaScript for you. And then you just start adding in types and increasing the compiler strictness. So as mentioned, out of the box, you can say, I'm going to allow for, if TypeScript can't infer the types of the objects that I have, then it gives what's called an implicit any. So you can turn that off at some point. You can say, I'm adding in all the types that I know about, but if you as a compiler can't figure it out, then don't allow this to compile forward. So then that gives you a hint as a developer that you have to give TypeScript some additional typing information in that file. You can also do the strict null checks, and TypeScript 2.6 has a new one about function strictness as well. So there's different tweaks that you can add to your editor or to your compiler that will slowly add in more type safety. And the cool thing about this is that, again, you don't have to do this across an entire code base at the same time. So you don't have to work as a team to go off on a corner somewhere. It doesn't feel like the same way that a Java 7 to Java 8 migration is. This feels like it's often easier. At work, we took our reusable component library, which is several thousand lines of code, and as we were still developing functions or features in that environment, we converted everything over to TypeScript and got rid of all of the implicit any's over the course of about a week. This felt like it was just me and one other person, so it feels like it's very doable. So allow.js, so you can also, from TypeScript, you can import JavaScript files if you turn this feature on. No implicit any is kind of the next step that you get to add in. Yes, Mike?
So you said that you took, several thousand lines of code and then we converted it from just regular JavaScript to TypeScript?
To type-safe TypeScript, yeah.
JavaScript code.
Yes.
Did you find any bugs while you were doing that?
So yes, absolutely. So that's one of the things.
benefits of doing this. Oh my goodness, we didn't know that this was a problem.
Right. That's one of the stories that I hear in almost every instance that somebody converts their project over from JavaScript to TypeScript, is that they find compiler bugs for bugs that they didn't even know existed, because that TypeScript infers that, oh, this just isn't possible for it to run, or there's a potential null value that just for whatever reason hasn't manifested itself in production yet, but it's still very possible for it to happen. So there's a couple of, this is just the grab bag section of the talk, where these are some additional features that I really like about TypeScript. You can, so if you want to assign stuff through a constructor, if you just specify that something is private or public, then those values will automatically be assigned to that class. So you don't have to write this.firstname equals first name. It just adds that stuff for you automatically. That's awesome. That saves me so many lines of code. Again, it's human readable output. If you look at this, so this is code that takes a class and compiles it down to ES5. But if I say ES6, then it's going to give me a class, right? This looks very much like code that a human being would write. And in fact, that's one of the ways that we are adopting it into at work, is we have taken our app scaffolding tool and we've rewritten it so that it outputs TypeScript. But we give our users the ability to say, would you like to use TypeScript, yes or no? And if they say no, then we just take the TypeScript code, we run the compiler on it once, and we give them the compiled JavaScript. So it's a very easy, and I think that most people are none the wiser, right? That a human being didn't write these JavaScript files. So that also means that it's a very easy escape hatch, that if you ever decide, oh, TypeScript is too much work for me, I don't want to deal with it anymore, just run the compiler on it once and save out your JavaScript files, and you're going to be good to go. Like, you're not going to get all this weird kind of garbage at the end. It looks like something that a human being would write, and I think there's some value in that. If you do want to, if you want to look at your original source files, then TypeScript also emits what are called source maps. And this is something that browsers, Node.js, most tools can read, and it can map from your compiled JavaScript code back to your original TypeScript code. So this, so we can see what this looks like. So this project, or this presentation, is written in TypeScript. So if I go to index, wait, oh, is this not working? Oh, this is going to be super embarrassing if this doesn't work. Here we go, okay. So I have my index.js, which is the compiled version, and I also have index.ts. So, you can see my import statements. There's not really a whole lot of types in here, so this isn't as exciting, but like you can see that I can look at my original .ts files and not have to do that mapping. You can put breakpoints in there, and so like you don't have to be an expert in managing the compiled output. Stuff just kind of works the way that you would expect them to.
So for compiled output, is that the minified?
So out of the box, yeah. So in my case, I'm not minifying the code. If you look at the index.js, it looks basically the same. TypeScript hasn't done a whole lot of work other than strip out the types. But if you did something that was more aggressive or minified, then it could take, like you would never have to read the minified code. You could look at the individual files that TypeScript, the original source files, and put your breakpoints and whatnot and step through them that way. Yeah, it's pretty sweet. So in this case, I have this TypeScript playground TS file, and so the code where I was clicking on source files and it was bringing me to that playground, that's non-trivial code. I have to make hash files out of it and do regular expressions. So I abstracted that out to a service, and then that service is doing its work. But I can like put breakpoints in. Oh, right. Well, I mean, we can see. So I have events that say every time that I call this that it should just work. If I step through the code, right, I get access to all these values in my original TypeScript files. So I don't know. I find that it's fairly useful.
Is the console value the right what you would expect as TypeScript?
So in here, I can't, like if I said const t string, that's going to fail because the dev tools don't understand TypeScript.
Oh, okay.
But if I make a change to my TypeScript files and I reload the page, then the source maps would work there.
That's been one of my biggest struggles in moving towards it using Angular now. With respect to that, particularly Chrome, since it's Angular that's using it, it's going to eventually start supporting TypeScript straight out of the box. Like context is completely gone from the console. It's really hard to make quick things.
So I found that so that's, yeah, I don't know. I haven't seemed to run into that quite as much. Like if you hover over code and then I think it's bang enter, that it can run that code in that execution, or you can kind of hover over things. You also get access to the call stack and the variables that have been defined. And all of that is TypeScript specific. So yeah, like if you wanted to just from here, you can still say viz dot something and it's undefined. If I step over this, I can still get access to those values. But you're right, like if you wanted to write additional TypeScript code inside those dev tools, that part doesn't work. And so that's kind of a bummer. That could be an entire presentation on its own that someone here should give. So source maps, flow typing, and we kind of saw some of this in here. So you can specify that a type has one of two options, but TypeScript can understand what those types are as your code is working through it. So in this case, you have your, this command is of type that's a union of either a string or an array of strings. But depending on what values you specify here, TypeScript, the compiler, can say, oh, I know that command here is definitely going to be a string because I've specified it here. Or I know that it's definitely going to be an array. So I can only give you the autocomplete that's specific to that particular section. That also lets you do type guards, so those conditionals, where if you have something that could be a value or null, if you verify that, that it's only going to be this type, then TypeScript will honor that in the context of that conditional block. So it will change its type automatically for you, and you never have to write any of those values. So that's super powerful, and it means that you get both type safety and very flexible code as a result. So I like that a lot. TypeScript, in fact, is so powerful that there was a developer that found a couple of months ago that the typing system itself, due to the recursive type definitions and the ability to map one type to another, was a Turing complete language in and of itself. So they implemented the Busy Beaver Turing state machine inside of TypeScript typing all by itself. So this is extremely powerful and probably too much overkill. In fact, the TypeScript developers removed some of the features that allowed for it to be a Turing complete language in the next release, which gave me the best halting problem joke that I saw, which is that, oh, the developer said, let's just detect ahead of time whether a type check will eventually halt. I really laughed about that. Anyhow, so there's a couple of other things that I found that to be pretty useful. So you can so there's a Maven and Gradle plugin that can take a Java class and can convert that into a TypeScript interface. So this might be really powerful if you have, say, a Spring MVC or a backend that you're writing in Java where you have a class and you want to map that to a RESTful service and then consume that on the front end. So you can, in theory, take your Java code, make a change that breaks that contract, and you can get a compiler error on the front end because that those types are no longer matching. This level of full stack type safety is something that you can do, I think, only on the Java to TypeScript integration side, and I would love to see somebody actually play around with it. I haven't done it yet, but I need somebody that knows their way around Java these days to actually build it for me. But yeah, this is just a Maven plugin, and I think that there's a Gradle plugin for it as well. So you can just add this into your system, to your JHipster setup, and things will just work the way that you would expect them to. So I don't know. I find this stuff to be super powerful. So in terms of so just to show you kind of what this looks like. So this is the code base that I was working through. This is the TypeScript code that was originally running this stuff. So there's some cool stuff I just missed. So if I remove the import here, and if I do TypeScript playground service, it knows about the different types in my code base. And if I hit enter, it automatically adds the import for me, from here. So that's something that we didn't have this. This doesn't exist in JavaScript, but we just take it for granted on the Java side. So the fact that I can get this back while also not having to deal with the JVM is it's so great. I love this stuff. So I think I have a few minutes. So one thing that I wanted to show, has anybody heard of the speech recognition API in JavaScript? So it's something it's built into some browsers, and you can speak and it can return values back. There's a third-party library called onyong.js that's great. It's speech recognition, and so you can say hello. Oh no, internet! Let's try this one more. Okay. Hello. Woo! Internet's working. So if you wanted it, so this is working. So if I wanted to add this in, but I wasn't real familiar with the way that the code base worked, it might be from Arrested Development. So I've added in some typings for it when they're fairly simple. But if I do window.onyong. Let's just say that I want to start And if I call this, so it's looking at the JS doc that's available, and it says, oh, start listening. It's probably, you probably want to add some commands first. So maybe I can do that. Window.onion dot add command. No, not add callback, add command. And so here's some examples. So if I say hello, then it runs this hello function. So maybe if I do forward, and this will do slideshow dot go to next slide. So if I did this right, and so I wrote my code, so I have a TypeScript compiler that recompiled my code. Let me go back to here, reload my app. I'm going to allow you to access my microphone. Let's see if I did this right. Continue allowing microphone, built-in microphone. Okay. Forward. Forward? Oh, man. That is a good question. So it takes an object, so it's just a map. So I can wrap this in a string. I don't think that would make a difference. In fact, Prettier is not letting me worry about that. Okay. Yes, so whatever keys you have. So if I wanted to make this into a, if I want to say go forward, then that would capture it. Let's just see if I can get this to work. Kill this. Kill this. Okay. Reload. If I don't get this to work, then I'm giving up. But I think I can do this. Let's make this happen. Okay. Forward. What? Internet? Forward. Probably. Forward.
Make it easier. Go. Go.
All right, let's do that. All right, so I'm saying go. And I'm also going to pass in, there's this auto restart. And maybe that's also helpful. Okay, reload. We're going to get to this last slide if it kills us or not. All right, don't need that. Cool. All right. Forward.
Go.
Oh, you're right. Go. Hey! So that's all that I got. So I'm happy to answer any questions that you might have.
So from Java to JavaScript, and we have front end code that we would write, maybe some of us aren't using both, and we would use the build tools to produce that. We would have the TypeScript source files that we would run through the compilation. Are you checking both versions of the version?
I tend to just take the TS files and check those in. We're deploying our code to Nexus repository and NPM, so those compiled files, it's like, I mean, you do kind of what you would with a class file, I suppose.
Okay.
That's the general kind of rule that I have. But if you wanted to take your compiled code, you absolutely could do it that way. We just tend to only commit our original source files.
And then you would run it through whatever your minify or other file.
Right. Yep. Yeah, whatever tooling you either have or don't have in your environment is like all works pretty well with TypeScript as well.
So do you have the TS files in the same folder as the output files?
You can do that, but what I have is, so my source files are all available here.
Okay.
And then I have a lib file that produces my JavaScript,
Okay.
my source maps, and my typings files. So these things all just kind of get built out of the box. And this is the piece that I run through gitignore, but you could also check that in the source control if you wanted.
So whatever the best practices are is what I'm kind of
Right.
looking for.
Mm-hmm. Yeah, I tend to just take my TS files and treat that as the source of truth, as long as I can generate. And so, in this case, my script is just running TSC, which is the compiler directly. But if you wanted to add in, a shell script or a gulp script or a Maven command, like all of those things are valid options for you.
What would be the easiest way to add a link to
So there's a TypeScript-specific linter called tslint that works really well, and you can just add that in with an npm install. I think it's like tslint.org somewhere. So that will tell you you don't get the category of problems that you would with JSLint because the compiler is telling you a lot of those things out of the box. But there's still instances where you want to make sure that all of your interfaces start with an I, those sorts of things. So tslint will give you that as well. Those are just npm installs that you would install the way that a lot of other JavaScript tooling is set up. In addition to that, one of the tools that I've been using a lot is called Prettier, which is just a code syntax auto-formatter that also works with JavaScript, but it also works with TypeScript. So if I, and this just formats your code in a pretty way. So, and the fact that it works both with JavaScript and with TypeScript means that, that I don't have to think about am I indenting with 5 spaces or 6 spaces. Prettier is taking care of all that stuff for me automatically. Also works with your CSS if you have ugly CSS somewhere.
What a JavaScript was the concatenation of the two ways.
Yeah, so let's see what happens if you do that. So if you try to concatenate plus 4, 5, 6, you get a type error just saying, what the hell are you doing? Don't add 2 arrays of numbers together. TypeScript will, and so TypeScript will still compile all these things. It doesn't prevent you from being, from building a foot gun, but it will, it will warn you, and you can fail on those errors.
So you said you don't look at the compiled JavaScript.
I tend not to, yeah. The source maps generally take care of that mapping for me automatically.
I was going to ask if you ever find yourself going to it, or how often, and do you find yourself ever looking at the generated JavaScript for more complicated things, and that it's difficult to read? Because obviously simple cases are, like you said, human readable, but maybe if you get something that's more complex.
Yeah. To be honest, not that often, but that also is because the tool chain that we have at work is way more complicated and also concatenates and adds in UMD modules and uglifies it. So even if I wanted to look at that compiled source code, I wouldn't have a clue as where to start with it. It's basically bytecode at that stage. So that tends not to happen, but you could build a very big TypeScript complex instance, and there's the potential that that could be more complicated. But I found that the Babel transpilers tend to produce more obfuscated source code than what TypeScript gives me. So I tend to feel pretty good about the stuff that it builds out. So if you wanted to read it directly, you certainly could.
Didn't you say that there was Gradle and migrations that basically translated from Java classes into TypeScript?
So the Gradle and Maven plugins just run the Node TypeScript compiler under the hood. So you're still writing your TypeScript code, but you can, from a Gradle build, compile your .ts files into .js files. So it's parity in terms of features, but you still have to have Node.js installed and to use the TypeScript compiler. That also means that you don't run into the problem of because that I'm on the Java stack, that my tooling is all out of date, because it's just deferring to the current up-to-the-date Java stuff.
Are there things you don't like about TypeScript? What's something that you find that slows you down or inhibits you?
You have to be slightly careful about the tools that you're using. So if you want to write your code in JSX, say that you're writing React or something that's using a virtual DOM. TypeScript supports that, but if you wanted to add in some of the kind of crazy stage 0 features on top of React that TypeScript may not have added those into the language, or there might not be tooling that understands .ts files, and so you kind of have to use a slightly smaller subset of tooling. The good news is that I tend to find that those tools tend to work a little bit better, so it doesn't feel like it's a huge trade-off, but you don't have quite the insane cornucopia of tools that you would if you were just writing your code in JS. Oh no, battery's almost dead. Now's probably a good time for me to say thanks then.